Actually, a lot of the stuff that Francis was talking about, hopefully my bubble's moving a little bit in that direction and kind of unifying a little bit of the OR things that I've been trying to do with some of those prospects as well. So this talk is all about what we've been doing at the Ministry of Justice to take our forecasting processes, modernise them, automate them, and basically free up time to do more interesting stuff than kind of churning through Excel spreadsheets, which I'm sure will prick a few ears up in the room, I hope. So vague structure. They never tessellate quite like you hope. A little bit of context into the criminal justice system, a little bit of an outline of the change that we've put in over the last 6 months, some of the impact of that, and then, heaven forbid, a demo of the tool that I've been working on. So where do we start with context? We start with crime. That's the easy part of the model, that happens, and we're pretty sure about that. And then where it gets complicated is where everything else happens. So just for usefulness, the way that it's organised currently is that the Home Office has oversight over all of the police forces. There are about 43 territorial police forces in the UK. And that's not the Ministry of Justice. The Ministry of Justice is everything else. So once the police decide that they've got enough evidence to take someone forward, take them to court, it goes through the Crown Prosecution Service, comes to the Magistrates' Court, which is the sort of lower end court. It's where a lot of driving offences, TV licence stuff happens. And they have kind of limited sentencing powers. And anything that's a bit more severe than that goes up to the Crown Court, which is where you have judges, juries. That's where a lot of the focus in the court section is on kind of costs and things. And actually the Magistrates' Court, despite the fact it deals with much higher volumes, is generally a lot less cost problems with that, and you don't get all these big anomalous cases and things. So a lot of this talk is going to focus on this area here, which is the Crown Court. It's lost me.
There you were, selling it up.
Oh, I know. It's bloody run out of battery, isn't it? It's completely broken. Fantastic. So I'm just going to wave instead. So the Crown Court is where we're going to focus today, and that's the forecasting that I work on, is working the workload in the Crown Court. There are about 77 different Crown Court centres in the UK. That changes a bit, but oh, there we go. That's happened all by itself. Yeah, so there are about 77 different Crown Court areas, and all of them have pretty much the same data system, quite a bit different, but all the data that goes through the Crown Court, the kicker really is that it's all administrative data insofar as it's someone sitting in the courtroom poking it into the interface that they've got. Now, this system was built in the 70s or the 80s. It's an amazing system. It does a lot of things, but it's pretty difficult to design for sort of 40, 50-year lifespans. It's actually undergoing a big change at the moment. Well, it's undergoing a change at the moment. So it's kind of a lot of that has been the catalyst for ability for us to change our processes and kind of link better up with that new data source and all the changes that come with it. So a little bit of context is what happens in courts. So when people come into Crown Courts, generally you have several different people. Each of them has got a long list of indictments. So that's crimes that they are accused of by the police. So you might have a whole tranche of things that kind of are related. You know, if you commit a robbery or something, you might get your robbery offence plus a sort of violence offence plus a possession of a weapons offence, all that kind of things. And they're tried separately, tried together, but you're judged separately on each one. But you also can have several defendants in the same case. So they'll get put into the same folder. That goes to the various barristers on each side. And then through the court system, there are sort of preliminary hearings where you get the chance to stand up and say, yes, I'm going to plead guilty to some or all of the offences on my indictment, some or all of the defendants might do some or all of that process. So as you can see, it quite quickly gets a little bit more complicated than someone coming in for a crime and something happening to them. And then the real sort of cost centre in terms of Crown Courts is how much of that then goes on to trials. Now, a lot of things come out, if you plead guilty fairly early on, then actually the impact that your case has on the system is relatively small, in that you have a sentencing trial, but a sentencing hearing rather, but you don't go through all of the really intensive part, which is getting in jurors, scheduling when that's going to happen, and all of the complexity that comes with that. And what we notice at the moment is a lot of cases are getting longer and longer as just much more information, much more data-based information is also coming through. So that is sort of an increasing cost centre. And then there are other complications, like some people don't turn up on the day, some people can disappear completely, or all sorts of things happen, or you might stand up at the beginning of your 2-week trial and say, actually, I've changed my mind, I am guilty, everyone can go home. So trying to factor in a lot of that complexity and come up with a sense of what the workload is at the moment, let alone what the workload is going to be in the future for 77 Crown Courts across the country, can be quite difficult. And just to kind of finish the cycle, when judgments are made, you end up with some or all of the defendants getting tried, getting sentenced for some or all of the things on their original indictment, and they can get all kinds of combinations of things that happen to them as a result of that. So that's where our team comes in. This is me here. I'm the new one. I'm the only one with a face. We have a 5-person team that does forecasting in the Ministry of Justice, the guy at the top, and then the court side and the prison side. I work on the court side, so our stuff is all about upstream demand. We spend a lot of time talking about crime, talking about trends, and trying to come up with how that's going to feed into this workload, as I mentioned. And then the bit that goes on to, we feed as a pretty major input into the prisons model, which is trying to look at how many people are going to be in prison over the next 20 years or so. It takes a lot of time and a lot of money to build a new prison, and it's a pretty sort of non-linear response in that you kind of either build one or you don't. And that's either an expenditure of £0 or £500 million. So it's quite important to get that level and also get kind of probabilistic look at how likely you are to need that shoulder point to catch at some point. So our sort of 3 responsibilities are produce this big forecast every 6 months. We then keep an eye on what's changing all across the system. And that's sort of bridging all those gaps between the slightly disjointed areas where like the police do their thing and all the courts do their thing, and keeping an eye over that whole system. And then the main thing that we're all here to do is to generate and share that insight and take it to all the different places in the business where it's needed, and every other kind of external customers that want it. This is me. I really like maths. I really like public policy. That's why I'm here. I'm pretty new to all this. I only joined GORS, Government Operational Research Service, in September, and new to the MOJ. Before that, just for a bit of context, I'd done a lot of maths, hadn't really done very much OR. I did an awesome interest programming course, came to an awesome thing by the OR Society, and that really changed where I ended up, and that got me really into this kind of thing. And as I joined, it was a time of transformation in the Ministry of Justice, and sort of wider across government as well. I mean, that we've got this new data source I talked about, lots of new tools, we're moving to sort of cloud-based stuff, moving to open source programming languages, moving away from dusty old spreadsheets, basically. And then there's this kind of ever-drawing allure of automation as well. And what we're hoping that can do is it reduces the time here, and gives us more time to actually use our brains to generate better insight and share it, and really make use of the sort of the unique skills that we have as operational research, or at least the rest of the team have. So, part of the rest of the context of this, we've given you a little bit of context of the criminal justice system itself. This is a wider project that's going on in the government at the moment called the Reproducible Analytical Pipeline, or the RAP. This is a slightly boring slide, it's a little bit dense, I'm afraid. But there's kind of 2 models. On the left here, and sort of throughout will be kind of the orange one. This is about statistical publications. There are about 17,000 statistical publications that the government puts out. It's a really important, it's a regular product. And it looks pretty much the same every time with different numbers in. And what that really screams is automation. And the difficulty with the current method is that you have lots of dusty old spreadsheets, lots of dusty old, sorry if there's anyone that's a SAS representative here, but some sort of really, I don't like them, slightly archaic methods, dare I say it. And just the sort of where does quality assurance fit into this? Is it generally done at the end? It's pretty difficult to do. It's pretty difficult to keep track of all these marginal notes that everyone's done, the kind of little bits on sort of, you know, sheet 5, copy 2, on like version 1, final, not quite final 2. And it's kind of emailed around, and then eventually it gets into a Word document, goes into a PDF, and gets onto the website, hopefully in time. And what the general move is to try and package all this up and use a little bit of the kind of data ops and DevOps methodologies, and that I'm happy to talk about at length, but which is all about trying to automate as much of this as possible, build in QA from the start all the way through, have this kind of understanding and record of everything that goes on, why decisions are made, how they're made, and frankly be able to churn out these in sort of minutes rather than weeks. So what's our current forecasting process? Well, it actually has a lot of similarities to a statistical publication in that it kind of looks fairly similar every 6 months when we do it. There's a lot of the same processes that go on. We have to bring in the data, we've got to do something to it, we've got to come up with some insight. But where it changes is that we also have this difficult part where your brain comes in a little bit, which is that we can't numerically account for a lot of the kind of fuzzier parts of where it becomes really tricky, which is stuff to do with crime, stuff to do with the police, where you really need expert insight that's pretty difficult to put in numerically. So that the actual forecasting that we do is numerical-based forecasting. It's kind of the old Holt Winter's job, lots of that kind of stuff. But the real magic of it, if you can call it that, is trying to marry that with the insight that we get from our stakeholders, and we sort of take it a bit of a round on a roadshow and see what everyone thinks, and try and unify those two things. But in general, we have to somehow gather together all this data to start with. We then have to come up, layer on top of that kind of set of agreed definitions, which is okay. We've got all this different data, and what kind of happens is you've got somebody that does the first hearing and they type in the person's name, they might misspell their surname or something, and then they put in their case number, which is different at every court, because they might come in from a different court, and then they say, okay, well, he's had his first hearing, that's great, and then someone else is saying, oh, there's a hearing in this courtroom at this time, and it took that long. And there's someone else somewhere else who's doing their D&I monitoring that's saying, oh, all the defendants today, this one was from this ethnicity, from this group, this age. And you kind of get all of this disparate data. There's a lot of linking to do, and there's also a lot of other definitions to say, and that kind of flow chart of all the things that happen. What we eventually want is sort of an idea of what a case is and kind of give it a label of some kind. But as I said, you get multiple defendants who plead differently to lots of different stuff. They can have all sorts of different indictments. So sort of how do you end up accumulating that into kind of one case with one title? Because that's the unit that we really deal with in the court. So that's a really interesting process as well. And I've talked a little bit about the forecasting, how that works. And then again, the monitoring is a sort of similar product fairly regularly. So all of this screams that maybe we can do something that's kind of a halfway house between automation and kind of bespoke work. So the current way it works, this is actually a simplification, is that we have this big database called Crest, which was built in the 70s, which is a relational database. So we have all these different tables of all different stuff going on. And we pull that through, or at least we do, and then actually other teams pull it through slightly differently. And everyone ends up with a big old access database that's got a size limit on of about 4 gig or something, so you get some of the data, and then we've got, oops, I'm not going to show you that yet. And then we've got all of these queries that were written by someone who was really, really smart about 10 years ago, who's left the business. And that's a problem that a lot of businesses have, is that stuff was made with really, really good decisions at the time, and then people move on, but that actually ends up becoming the sort of incumbent wisdom, and it's really difficult to challenge that because you've lost a lot of the conversation that went along with that, and you've lost a lot of the reasoning, and if we had this slightly different, we could have done this, but we don't in the moment, so this is what we're doing. And that's the kind of subtlety that you lose. And we end up taking a load of different extracts. They quite often take overnight, they break, they don't give you what you want. And then there's a lot of copying and pasting that goes on. You put them into data sheets that you can actually use. We also grab other bits from other people that have done this same process. And then we eventually get into our big old model Excel spreadsheets. Lots of copying and pasting, as I say, and no real opportunity to check that any of this is right at any point. We do, by the way. We do try really hard to do so, but it's hard. And over the last 6 months, what we've been building, and actually the sort of court data side has been going on for longer, but it's been building a kind of alternative, which is on the right, which is kind of primed in green, if you hadn't noticed. That's good, by the way. We've got the same database, or roughly the same database. And then we've got this amazing automated pipeline. There's a thing called Airflow, which is calls itself a directed acyclic graph. So it's basically just like a semi-linear this needs to happen after this, these things can happen in parallel, this thing has to work before you can do this part. It's basically a way of structuring lots of programming jobs or other kind of jobs in that you get a kind of automated flow that it sort of checks its way through really nicely. And this guy manages a process of pulling in all this data, having it in a big data lake on the cloud, which is trendy, and then through a bunch of Python scripts which we control through GitHub. We have a full history of every decision that's made on all of those Python scripts about what we pull in, how we join what to what we're going to define, what we're going to make what. And then also some built-in testing, which we'll talk about in a bit. That gets pulled into this amazing product that's called the flat file. So that takes these 22 tables from this big relational database and turns them into one file where you get one line per case per defendant. And it's kind of difficult to sort of oversell how useful that is, because that means that you get this kind of central source that lots of different people in the business can access, not just our team, but pretty much anyone. And you know that all the definitions in there, where it says the hearing time column, that's been agreed on by experts, but you don't need to be an expert to understand it and to use it. And that really opens up our data in a huge way, in a consistent way that everybody can use off the same basis. And this then goes through some pretty easy SQL queries that, again, are GitHub controlled into our main model in RStudio. Nice things, I like cool tools. We start using Slack a little bit more. I get a little notification when there's a new flat file out or there's a new model release that's out, and I can tell anyone I want about it without having to worry about it. So just lots of really cool new tools to try and automate as much of it as possible. I'm actually going to skip through this pretty quickly and get to the demo. But the bottom line is that at pretty much every stage of our process, we managed to, in not a very long time, pretty much transform it. So we've gone from these kind of slow and error-prone data processes to an automatic, self-populating and reliable data source that checks itself, really. We've got these kind of opaque and forgettable definitions that turn into this amazing conversation that we've kept recorded through Git and through GitHub of like what everything means, why we've chosen to do that, and all the reasoning is there. The forecasting is then done on the data. Lots of stuff is done in parallel. Before we had to kind of do each little forecast we wanted for each different offence. It took a lot of time. Now we do larger stuff, and I'll show you where that ends up. And then we've got this kind of graphical interface that we can display the work that we've done with our stakeholders and do this kind of run round that we do in a much more dynamic way. And then the monitoring comes out really cool as well. So without further ado, I'm going to pile into the demo. This is a 3-minute demo of the tool we've built. So here, you get onto this. This is actually a web URL. It's a deployed web app. You get in there, you choose how much data you want to use, where you want to start forecasting. We're going to go back to September here. We're going to choose where we want the data to be. So we've got the full history of what the data has looked like at all points in the past. It updates every month. Here we're going to use data from the end of last year. We're going to make a new forecast called new to OR September. Runs like nothing else. That was actually sped up slightly. You save it into a table of all the forecasts that we've got. You can see how they all work. It's going really fast. And then this is the interface that our customers see. Can I pause it? Can I pause it before it gets too messy? Oh yeah, I can. Just as I mentioned, all this data is obfuscated, which is a really interesting problem in itself. All of the offences here are real offences, but they're quite silly. So there's a digging for badger one, abstracting electricity, handling salmon in suspicious circumstances, which is the one we're going to focus on. And what we get is you get a complete rundown of it's run loads of different forecasts for all these different offences, and it's done statistical tests on whether we've got error, whether we've got trend, whether we've got seasonality. The only one we've actually found seasonality here is about removing soil from a highway, which you might imagine is better in the summer. And you can sort of select what offences, what collection of offences you want to see here. So we're gonna pick out the where's it gone? Removing soil or turf from the highway, and then we're going to see what that looks like. We've got a forecast period here. We can actually smooth out the effect of working days and holidays, so we can see the seasonality coming out properly. You get a little bit of a hump in the summer, and also some Christmas turf, I think, over there. And then we're going to look at something that's got a bit more interesting shape. And this is about handling salmon suspiciously, as you do. And the decision that we really have to make is, what is the kind of baseline that we're going to use? We kind of unify. This is where our kind of insight comes in, is where are we going to set this base level? We're going to use the seasonality that we've got. Are we going to set it to reflect broadly this area, kind of recent trends? Are we going to sort of come back up here? And the sort of choice that we make with our customers was kind of the decision that we kind of make is that we either going to choose like a 12-month history, a 6-month history, a 3-month history. And all of those forecasts are computed in parallel. And then we choose between them here. We'll do it. Choose between them here, and you can sort of click through and you see what's the incumbent, what's saved down here, and what a different one would look like, how that compares. And you can kind of click through, and then we've got all sorts of extra knobs and whistles. So this is an Ets forecast, which is a different way of forecasting. What would that say if it used a sort of exponential type forecast? That suggests that it's closer to the 6-month thing. So maybe in discussion with our stakeholders, we'd say maybe that looks like the right thing to do. And at that point, we come down here, and we're going to record that in our table of assumptions down here. They get saved, and then we export the whole thing as a kind of saved group of assumptions plus all the forecasts we want to use. It aggregates it up, gives you what you want. Extra cool thing we can do is if we think something else is going to happen, like there's going to be a really big, say a 40% increase in stealing of salmon in like 2020 or 2022, we decide, this is between 2019 and 2022, it's going to take a couple of months to bed in, it's going to be a ramp up, ramp down, all kinds of offences of this level are going to go. We can flick that on and you see that bumped up in the forecast there in a really nice graphical way. Where are we now? That's really most of the kind of interesting decision-making part. We then have other sort of plugins. What does that mean in terms of financial years? It's a really important unit for us. You get this kind of summary table of sort of comparing any two forecasts that we've done before, how that works, and all of these different offences, where the sort of percentage changes. It needs a little bit of a redesign. Yeah, that's the kind of product we've got at the moment, which I think tries to unify those changes that we've got methodologically to kind of a nice way of interacting with our customers as well. Whew. So these are the cool bits. This flat file I've talked about quite a lot. Is an amazing product. You sort of go from the forecasting time, the actual active forecasting time, about 2 weeks of faffing with all this various data to 2 hours or less than 2 hours if I'm doing it, because I know what I'm doing. We get this really cool shiny app that we can use that actually people can look at themselves, they can come back to, they can look at the decisions that were made. And the bit that I'm really pleased with, I'm working on at the moment, is that we also get a monthly pack that gets sent to me every month without me having to do anything, that says, have a look at these offences. I'm going to give you the top 5 offences that I think you should look at this month, because we've all got sort of limited time, and it kind of posts those to me that it thinks are of concern at the moment. And that's a really nice product, and that's just the kind of thing that is kind of opened up by doing all of this. So all along the way, testing is a really important part of this. Build in testing to the cycle. Statistical quality control is really important. Lots of cool stuff. Had a bit of a go at machine learning, and just this new data source really opens up all that kind of thing. So I'm really sorry to rush through that. But that's the kind of work that we've been doing, and this is the kind of work that we'll do. Thanks.